Greenhouse gases have a major impact on climate change. That's why Hydro-Québec monitors the GHGs emitted by its reservoirs and by aquatic and terrestrial environments to properly document the carbon footprint of its activities. Reliable and rigorous studies have made Quebec home to the world's most extensive datasets on the GHG emissions associated with hydroelectric reservoirs. In aquatic environments, there are two main greenhouse gases: carbon dioxide, or CO2, and methane, or CH4. To quantify the GHGs emitted by a reservoir, the concentrations of these gases in the water must be measured. However, it's very difficult to check the levels directly in water, so experts rely on indirect methods. In natural bodies of water and reservoirs, emissions are mainly released by diffusion. We use three methods to measure them. The first is headspace sampling. A water sample is collected in a flask and inert gas is added to create a space between the top of the flask and the liquid. Then the contents are stirred for a few minutes to speed up the process, by which the liquid and gas reach what's known as phase equilibrium. The next step is to analyze the gas concentrations in the gas phase. That's usually done in a lab. The second technique is the direct flow method. A floating chamber is temporarily placed on the surface of the reservoir. Because gas concentrations are higher in water than in air, it takes only 10 to 20 minutes for the gas concentrations inside the chamber to increase. The chamber is connected to a GHG analyzer that measures emissions on the surface of the reservoir in real time. The third technique is flow turbulence, which measures emission flows directly in the atmosphere. High-frequency measuring instruments that record 10 readings per second are installed on measurement towers on the shores of a reservoir or on a floating dock. In addition to diffusive emissions, reservoirs also emit GHGs by bubbling. To measure these emissions, inverted funnels collect the bubbles that escape from the water. An analyzer then calculates the volume accumulated over a given period, as well as the gas concentrations. This technique, which used to only be available in the lab, is now possible in the field. All of these GHG measurement techniques require teams of experts who gather data from across Quebec. Some Hydro-Québec facilities are also equipped with automated systems because degassing, a GHG emissions process equivalent to diffusion, occurs downstream of generating stations. The automated greenhouse gas measuring system quantifies the CO2 and CH4 concentrations in the water that flows through the turbines. While it's impossible to take field measurements in winter, this type of automated system can check gas concentrations year-round and further expand our knowledge. Whether from boats and seaplanes, on shores and floating docks, or in generating stations, we work hard to methodically track and document the GHG emissions released by our facilities. These different measurement methods combine to give us a comprehensive and accurate picture of the impacts of our facilities. That's how we can be sure that Quebec's hydropower is a low-carbon energy source, and we can prove it.